Today we're going to start Unit 4, and this is about writing inequalities. So in Chapter 3, we dealt a lot with expressions and equations, and now we're taking all that information and applying it to inequalities. So what is an inequality? It's a mathematical sentence that compares expressions. So what we're going to have is we're going to have information on one side, information on the other, but instead of an equal sign, it's going to be a greater than or less than symbol because they are not going to necessarily be completely equal. They could be in some instances, but not always. So if you could, pause your screen and put this chart in your notebook with all of the phrases that match up to its symbol. Pause. Now that you have written all those phrases down, you have them as a reference. So if we're going to take this sentence and put it into an inequality, we have a number t. Now, it says is less than or equal to. Now, in the past, you guys saw less than and you thought flip phrase, but this one is not that case. Less than or equal to, you can see it in our chart right up here, is less than or equal to. So as long as you keep the order exactly the same as your sentence, you can use the symbol the same, or equal to 5. That is your inequality. The next one, a number g subtracted from 6. Okay, g subtracted from 6. So this is going to have more than just one thing on both sides. If g is being subtracted from 6, I have to put 6 first, then minus g. And that is going to be no more than, I did not finish this. We're going to say no more than 12. So if I say no more than, we can find that in our chart in the same section. Okay, if it's no more than, that means it's going to be less than, but it could also be equal to. And the gator, it always opens towards your bigger amount. Okay, you have at most 30 games on your smartphone. So, games on your smartphone. Let's use G for games. You have at most 30. So I know 30 is going to go on the other side. Now if I have at most 30, is 30 the greatest thing or is the games the greatest thing you have? At most would be 30 is the most you could have. You could have 30, but you're going to have 30 or less. So that is why we use the phrase that way. You need at least 16 correct answers, in order to pass the science quiz. So I could say A for answers, and we know we're going to talk about that compared to 16. So I need at least 16 of them correct. So do I want the answers more correct, or do I want 16 to be the bigger number? I want the answers to be bigger or equal to 16, because if I get 16, I'll pass. But if I get more than 16, I'm for sure going to pass. So this is just some practice in how to use those symbols correctly. Solutions. A solution of an inequality is a value that makes the inequality true. So it's one number that will make the inequality true. Where a solution set is multiple values or all the values that will make an inequality true. Now if I say something is less than 4, there's really an infinite number of possibilities unless we categorize it with a situation. But if I say t is less than 4, okay, you have 3, 2, 1, 0, and all the negative numbers. So your solution set is actually very large. So there's two ways we can decide if something is a solution or not. We can substitute the variable for the given value and solve. So that means we can plug in 8 for the first one and see if it works. Or decide if the value would be part of the solution set after you've solved it like you normally would. I prefer to plug it in and solve to see if it works. So let's do that. So they're telling me that R is 8. So let's take this 8 and let's put it in for R. So 8 minus 3. Is it less than or equal to 9? Because remember, it eats the greater thing. So what is 8 minus 3? It's 5. Is 5 less than or equal to 9? Yes. So 8 is a solution to this inequality. It's not the only one, but it is one. Question number 2. They're telling us that h is negative 5. So let's put a negative 5 in here. If I do 4 times negative 5, is that going to be greater than negative 12? Let's check it. 4 times negative 5 is negative 20. Is negative 20 greater than negative 12? No. So negative 5 is not a solution to this set. Here we go again. K is 13. Let's plug it in here. If I do 14 minus 2 times 13, is that less than 12? So we have to solve this. I first have to follow PEMDAS. 2 times 13, that is going to be 14 minus 26. Is that less than 12? So if I do 14, take away 26, that leaves me with negative 12. Is negative 12 less than 12? Yes. So 13 is one of the solutions that works for this inequality. Graphing. You definitely want to have this in your notes. It is super, and of course, I went back the wrong way. Sorry. You definitely want to have this in your notes about open and closed circles. Once you get the hang of it, it's a very easy idea. An open circle means that the number that you put your circle on is not a solution. If you used a closed circle, that means that number is a solution. So you need to shade it in. So it includes that number and everything else that you go with. So if we are looking at the first question, y is greater than, because it eats the greater thing, so y is going to be everything bigger than negative 1. So I'm going to make my number line, and I'm going to put negative 1 in the middle, and then 0 would go to the right of it, and I'm going to put negative 2 to the left of it. I really typically only need 3 numbers on a number line, but you can fill in more. So you definitely want to be doing this in your notes right now. Now, y is greater than negative 1, so my circle is going to go on negative 1. But could y be negative 1? No, because then it wouldn't be greater. So that's why I leave it open. And then everything greater is to the right. Now, I like to think about the situation if y is greater than negative 1, it's going to be all my positive numbers, and positive numbers are to the right. But there is a little trick. If you have the variable on the left side, if you notice my symbol makes like an arrowhead, and that arrowhead is pointing to the right. So that's one way that you could do this, but don't rely on that completely. A is greater than 1.25. So I'm going to put 1.25 in the center. And now you can count by anything you want to. I'm going to count by 0.25s just for fun. So if I go 0.25 bigger, that would be 1.50. Think about quarters. If I go 0.25 smaller, that would just be the number 1. So now I'm going to put my circle on 1.25. And I think, could A be 1.25? No. It is just everything greater. And it could be super duper close to 1.25, but not exactly. So A is greater because it eats the greater thing, and that goes to the right. S is greater than or equal to 3 3/4. So I'm going to put 3 3/4 right here. I could count by ones and put 4 3/4 over here. And then on the other side, I could put 2 3/4. Or you could have counted by fourths, and you could have done 3 3/4, which a fourth bigger was 4, a fourth less was 3 2/4. So it really doesn't matter how you show this, but as long as you show right is bigger, left is smaller. My circle goes on 3 3/4. Now, could it also be equal to 3 3/4? Yes, so you have to shade that circle. And now it's everything greater. Greater goes to the right. There's your arrowhead. The last problem. If you want to try this one on your own, go ahead and pause your screen. But this one is tricky because it's set up a little bit different. This one says that -7 is greater than m. So if I'm doing negative numbers, my number line will look like this, because the greater the number, the smaller the negative it is, or the smaller it looks. And my circle is going to go on -7. But it says -7 is the greatest thing. It says m is everything less because it's eating the -7. So that means that my little arrow trick is not going to work. M is everything less than to the left. That's why I think it's really important that you understand what an inequality is worth, and that it's eating the bigger thing and how to properly say it, rather than relying on that arrow trick. Now, how do we write an inequality from a graph? Okay, you can use any variable you want. I'm typically going to use x or y, but it doesn't matter. So in this case, I know I'm going to have x, and I know I'm going to have 3. Now, it is a shaded in circle here, so I know it can be equal to. Now, x, is it everything less than, or is it everything greater than? Okay, what this shows me, it's on 3, and 3 is the greatest thing that it can be. So x is going to be everything smaller than 3, or equal to. If I choose y for the next variable, and I know I'm going to compare it to -4. So all my solutions are going to be greater than -4. They cannot equal -4, but they could be greater. So I'm not going to have the line underneath. And then I got to say, so does it eat the y, or does it eat the -4? When I say eat, the inequality opens towards that number. So I'm going to say that since y has to be greater, it is going to open towards the y. And there you can see your arrow trick does work as long as your variable is first. And the last one, go ahead and try the last one on your own. Pause your screen and then see if you're right. I'm going to use variable f compared to 8. In this case, it is not equal to, and f is everything smaller than 8. So I know that 8 is the greatest thing that it can be, and f has to be smaller than that 8. So that would be your inequality for that one.